Good evening, everybody. This evening, I'm going to share with you Polya's problem solving strategies. Let me introduce George Polya. He is a very noted man, especially in problem solving. The main question is, who is George Polya? Let me read a historical highlight. By the way, when we make our lesson plans, there can be a part of our lesson where we place historical notes, or for some, they call it historical highlights. And these are ways to motivate our students. And here's the historical highlight for George Polya. We could argue that George Polya is the father of problem solving, as we teach it in so many of today's mathematics books. As a youth, Polya decided to study law, but because of his dislike for memorization, he found it tedious and eventually chose a career in mathematics. While working as a mathematics tutor, he began to develop a problem solving method that led him to write a book called How to Solve It. It was, I think, about 1945 when Polya started writing the book How to Solve It, and it was translated into 17 languages. This book, which has sold more than 1 million copies, discusses many of the approaches to problem solving that you will learn in this section. Polya loved to solve problems, and it seemed that he could find them everywhere. One day, while he and his wife to be Stella were walking in a garden in Switzerland, they encountered another young couple 6 times. Polya wondered what the likelihood was that they would meet the same couple so many times on the same walk. His attempts to answer that question eventually led him to publish research papers on the topic of the random walk problem. In the 1940s, due to their concern about the increasing influence of Nazism in Europe, George and Stella immigrated to the United States. Polya eventually accepted a position at Stanford University in California, where he conducted research and work on problem solving until he was well into his 90s. That's a short historical highlight about George Polya. Now, how has Polya influenced the world of problem solving? There are so many authors that has taught us on different ways to solve the problem. But so far, Polya's four-step method is the most widely used. Let me introduce to you Polya's four-step problem-solving method. The first is understand the problem. Step 2, devise a plan. Step 3, carry out your plan. And step 4, check your answer. Let me use another material written by University of Berkeley to illustrate these steps. The first principle is understand the problem. We first ask, do you understand all the words in the problem? If not, then do a further research. Second, what is the problem all about? Or what are you asked to find or show? Third, can you state the problem in your own words? Then, can you picture out what the problem is all about? And is there enough information to help you solve the problem? That is the first principle of Polya, the first step. Understand the problem. The second step is devise a plan. Polya listed some strategies on how we can solve word problems. We have, as you can see in the screen, there are 14 strategies being written, but some will go to 21 and some beyond that. And we'll deal on these strategies one by one. So in the devise a plan, we ask, what is your problem-solving strategy? The third is carry out your plan. In carrying out your plan, remember in step 2 in devising a plan, you already thought, how am I going to solve the problem? So this time, we are going to see if I'll use this method or this strategy to solve the problem, then what will be the output? So this is the real problem solving time. And the last is look back, looking back. Or for some, they call it check your answer. In some books it says verify your answer. Or basically in our layman term, we use the term checking. We do checking to see if our answer is really correct. So these are the 4 steps of problem solving using Polya's method and principles. Again, step number 1, understand the problem. What is the problem all about? Step 2, devise a plan. What's your strategy in solving the problem? Step number 3, carry out the plan. You need to start solving the problem using your strategy. And the last is look back or check your answer. Now, here are some examples on the strategies in problem solving as outlined by George Polya. The first strategy we're going to talk about is drawing pictures. Give me a moment because I could not see my arrow. Okay, now. Still, I could not see my arrow. Okay, let's just continue. The first strategy is draw pictures. Like when you are asked a problem, your first strategy might be you'll draw a picture so that you can visualize the problem. This is very common, especially when we solve geometry problems. Like for example, there's a rectangle and the length is 15 meters and the width is 10 meters. What is the perimeter of the rectangle? Sometimes to help us visualize the problem, we'll start drawing a rectangle and start labeling the sides. Like when you draw the triangle, this one is 15 meters and the width is 10 meters. And this one is also 15, this one is also 10. So that's the first step or the first strategy. We draw pictures. Or another, when the problem is about triangles, you really want to draw the triangle so that you can solve the problem. Here's a sample problem, a non-geometry problem, where you can apply the strategy, draw pictures. 4 architects are meeting for lunch to discuss preliminary plans for a new performing arts center on your campus. Each will shake hands with all of the others. How many handshakes will there be? Let's start. What's the first step? Understand the problem. What is given in the problem? There are 4 architects and they're going to do a handshake. So it means that you'll pair each architect. What are we asked for? We are asked on how many handshakes will there be. So let's do step 2, devise a plan. Our strategy is to draw pictures. Like you could start drawing architect 1, architect 2, architect 3, and architect 4. Then start making lines like if it's architect 1 and 2, architect 1 and 3, architect 1 and 4. So that will be our strategy to draw pictures. This time, let me show you the figure in step 3 in carrying out the plan. In this material, what happened was they start plotting. We have architect A, architect B, architect C, and architect D. And to have the handshake, because you see, you're just pairing them, right? So we say architect 1, A and B. That's one handshake. architect A and C, architect A and D. Next, let's go to B, architect B and C, architect B and D. We're done. Then we'll go to architect C and D. So if you count, there will be 6 handshakes. This is the drawing strategy. Again, our first strategy is draw pictures. So if you check, you could go to the formula to look back, or you could simply make the diagram again. So that is the first strategy, draw pictures. Let me have another problem. In how many different ways can you flip 3 coins? So step number 1, let's understand the problem. What's the problem all about? There are 3 coins and you're going to flip them or to toss them. What's the question? We are asked how many ways can we flip 3 coins? This is a probability problem. So what comes to your mind in step 2, devise a plan, is to draw a tree diagram. So let's carry out the plan in step 3. Here, sometimes in statistics, we just use head and tail. Then second coin, head, tail, head, tail. Third coin, head, tail, head, tail, head, tail, head, tail. So imagine there are 3 coins. This is US-based, so the terms are penny, nickel, and dime. But you imagine this in the Philippine setting. We have 10 peso coin, 5 peso coin, and 1 peso coin for the dime. So for the 5 peso coin, we have either the head or the tail. Sorry, I could not see my arrow. For the 5 peso coin, we have head, tail, head, tail. For the 1 peso coin, we have head, tail. You do it alternately. Head, tail, head, tail, head, tail, head, tail. So it means that the first way is you start from the penny. Head, head, head. The next output is head, head, tail. Tail for the dime. Next output, still head for the penny. Head, tail, head. Next output, head, tail, tail. Next output, we go to the tail now in penny. Tail, head, head. Next output, tail, head, tail. Next, tail, tail, head. And the next is tail, tail, tail. So if you count, there are 8 outputs. There are 8 ways to flip 3 coins. Any questions? Feel free to message me in the chat box in Messenger. The next strategy is choose good names for unknowns. For example, problem number 3. There are 50 students. 15 would like to take swing lessons and 20 would like to take Latin dance lessons. Among these, 5 likes to have both. How many are neither interested in swing nor in dance lessons? Now, the first step is understand the problem. Like you say, what is the given? And what's the problem all about? You're asking how many are not interested in swing nor in dance lessons. So you could imagine that you'll be combining 2 strategies in the devise a plan. We can draw the pictures because this is a problem for Venn diagram. And second is you could name the unknown. Here's a sample. Like, let me just use this one so I can annotate. Okay, we have here, let's go back to the previous problem. 15, 20, and 5. Okay, let's have this one. Like we draw the pictures first. This is the circle for the first one, and the circle for the second one. And now we are going to name the unknowns. Like, what is this circle for? So you name it. This is a circle for S. It means those who'd like to take swing. Next, this is for L. What is L for? These are for those who would like to take the Latin dance lessons. But you need to name each unknown in the space. Example, what is R1? These are the ones who don't like to take neither swing nor dance lessons. What is R3? This is the intersection. So these are the ones who would like to take both swing and Latin dance lessons. What is R2? These are the ones who would like to take swing, but not Latin dance lessons. What is R sub 4? These are for the ones who would like to take Latin dance lessons, but not swing. When you make a Venn diagram, we start first with the intersection. Based on the problem, 5 would like to do both. Next, for swing, let's go back to the problem. I could no longer get back. We check. 15 would like to take the swing lessons. So from this circle, we already got 5. So it means your R2 is already 10. Next, for Latin, how many would like to have it? There were 20, but you already got 5. So how many will be left for R sub 4? You'll have 15. But remember, there are 50 students. So we add first the circles. That's 10 plus 5 plus 15, that's 30. You subtract it from 50, it means there are 20 students in R1. What's R sub 1 again? These are the students who don't like to take any of these 2 lessons. So we go back to the question. What's the question? How many students are neither interested in swing nor in Latin dance lessons? The answer is 20. Now let's go to the next one. Give me a moment. Okay, let's go to the next one. The next strategy is be systematic. Now, if you approach a situation in an organized, systematic way, frequently you will gain insight into the problem. Now, how can we be systematic? Polya suggested that we can be systematic when we make tables or when we list the possible outcomes. For example, let's take problem number 4. Javier is buying an iPhone and is considering which optional feature to include with his purchase. He has narrowed it down to 3 choices. The choices are battery, earbuds, and an 8 gig memory. Depending on the price, he will decide how many of these options he can afford. The question, in how many ways can he make his decision? So what will be the first step? The first step is understand the problem. What's the problem all about? It's asking you how many ways can he make his decision or how many outcomes are possible. Let's have step number 2, devise a plan. Let us be systematic. Let's make a table and try to list the possible outcomes. Step 3 is carry the plan. So here, your first outcome is no battery, no extended life in the battery, no earbuds, no gigabyte. No, not 8 gigabytes. The second is you just choose one. Only one is available. Yes to battery, no to both. Or yes to earbuds, no to both. So what's the next one? Yes to 8 gig, but no to battery and no to earbuds. The next, choose 2, like 2 are present. These 2 are present, but it's not 8 gig. Or battery and 8 gig are present, there are no earbuds. Or what's the other one? Earbuds and the 8 gig are present, but not the extended life battery. And the last is all 3 are available. So if you check, there's 1, 2, 3, 4, 5, 6, 7, 8 options available. Or we can go back to the problem on the 4 architects, remember? Like we can start, we can do this problem using another strategy. Like you can start listing them. For example, here's my answers. Let's name them architects A, B, C, and D. So we say we have the architect AB for the first handshake, architect AC, and architect AD. Next, let's go to architect B. B has a handshake with C. We could not do B and A. Why? Because A and B are just the same as B and A. The next is architect B and D. We're done. We're going to architect C. Only D is left. So if you see how many are there, there's 1, 2, 3, 4, 5, 6 handshakes. Same problem, but we are using a different strategy. Now let's go to the next one. Let's first clear it. Let's go to the next problem. The next strategy is look for patterns. I think as math majors, we are very good in looking for patterns, and we'll do more in mathematical investigation. So problem number 5 is asking us to construct Pascal's triangle. Here's a sample. Like step number 1. What's the problem? You need to construct Pascal's triangle. So you need to first ask, what do I know about Pascal's triangle? So far, you could start writing with Pascal's triangle. Like you know it's only 1, then 1, 1, then 1, 2, 1. Step 2 is devise a plan. Your plan is to look for a pattern. So let's go to step number 3. Let's carry out the plan. You see, based on the triangle, 1, all the outsides are all 1, while the in-between are the sum of the first 2. Like example, 1 and 1, that's 2. So if you make another row, we are sure it's 1. What's next? 1 plus 2 is 3. 2 plus 1 is 3. And 1 in the end. So as you continue with your Pascal's triangle, you will end up here. This is our Pascal's triangle. And you see the pattern? 1 for the last. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And the next one, still 1 in the end. But 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. And 1 in the end. So even if you'll continue with the Pascal's triangle, because you already got a pattern, then you can complete the Pascal's triangle, even to the number of rows being indicated. The next problem is still looking for patterns. Solve for x, the quantity x plus y to the 5th power. You know, it's an application for Pascal's triangle, right? And how to look for the pattern? You know the coefficients are 1, 5, 10, 10, 5, and 1. And you see the pattern? The pattern is for x, the exponents is decreasing. For y, the exponents are increasing. So if we have this one, let's expand it. We have x to the power of 5. I'll just use the caret sign. The next is 5x to the power of 4. Then you start with y. The next is 10, because it's 10 here. 10x to the power of 3. And our y is now increasing. Y to the power of 2. The next is still 10, but our x is decreasing. X to the power of 2. And your y is increasing. Y to the power of 3. Next, 5. 5x to the power of 1 and y to the power of 4. And the last is a y to the power of 5. So you see the patterns? For x, the exponent is decreasing. For y, the exponent is increasing. For the numerical coefficients, you go back to the Pascal's triangle. Next one. Let's go to the next strategy. Still, by the way, look for patterns. List the first 10 numbers of the Fibonacci sequence. Step 1. What's the problem? You list the first 10 numbers of the Fibonacci sequence. Step 2. You know it's a sequence, so try to look for patterns. You'll have the look for patterns as our strategy. Step 3, devise the plan. You know it's the first is 1, 1, then you add the first 2. So 1, 1, 2, 3, 5, then you keep on adding the first 2 numbers. That's for the Fibonacci sequence. Like for example, you have 1 and 1, then you start adding the first 2. 2, then 2 plus 1, 3, 2 plus 3, 5, 3 plus 5, 8, 5 plus 8, 13, 8 plus 13, 21, 13 plus 21, 34. How many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. Next, 21 plus 34. That's 50 and 55. So we continue. That's the Fibonacci sequence. The next strategy, let's first make a checklist. We are done with make an orderly list. This is be systematic. Look for a pattern, draw pictures, and name the unknowns. We still have more coming. Ready? Let's go to the next one. No, this is not the correct problem. Let me show you the other one. Give me a moment. Okay, here's the next strategy. Try a simpler version of the problem. Sometimes problems are too complicated, and we need to start with a simple one and make a pattern out of it. So for example, problem number 8. This is being posed. Remember last time we had the topic posing a problem. And this time I'm posing a problem by changing the number, the given. So numeracy, right? Change the numeracy. Instead of 4 architects, we'll now have 12 architects. So there are 12 architects and each of them will do a handshake. How many handshakes are there? Now to start with, you could not do the first strategy. So we start with step number 1. What's the problem? We need to see how many handshakes are there. Step 2 is devise a plan. But this time, you could not do drawing pictures because there are already 12 architects, and your what's this? That these ones might be too many to draw. Second, you could not list them also because there are too many to list. So, what can be the best way? We'll try finding a simpler version of the problem, then we make patterns out of it. Like, for example, this is just the number of branches, but let me change the problem. The first column is for the number of architects. The second column is for the architect's name. The next column is your listing. And then the last is the number of handshakes. Okay, there. So if you see, for example, if we only have one architect, so you can see it well. Okay, there. If you have the number of architects, like you only have one architect, that's only architect A, there's no handshake, right? But if there are two architects, architects A and B, you only have AB for the handshake. That's only one handshake. If you have three architects, you have architects A, B, and C, then you'll have handshake AB, AC, and BC. Based on our problem number 1 a while ago, if you'll have four architects, architects A, B, C, and D, then you'll have 6 handshakes. Then you continue. Remember, there are 12 architects, right? So if you see the pattern, 0, 1, 3, 6, and 10. What's the pattern? This one is add 1. You add 2 becomes 3. You add 4 becomes 6. You add 5 becomes 10. So with that pattern that you have, we first clear it. You arrive to this table. Let's edit the table. These are the number of architects, and at the bottom is the number of handshakes. So if you continue adding 4, 5, 6, 7, 8, 9, 10, 11, you'll see the pattern that you will have 66 handshakes for 12 architects. The last strategy for tonight is guessing is okay. This is very common among us. We try to guess. Sometimes you're afraid to guess because you are afraid of getting wrong. But in problem solving, guessing is okay. Like you guess and you try to check. Like step number 1, identify the problem. Step number 2, devise a plan. We'll do guessing. Step 3, you guess. And step 4, you look back. Is my guess correct? If not, then you guess again and then you look back. For example, here's a simpler problem. Mr. Jones has a total of 25 chickens and cows on his farm. How many of each does he have if altogether there are 76 feet? So sometimes we do it in algebra, right? Like x plus y equals 25. Then since the chickens have 2 feet, then 2x, and the cows have 4 feet, 2x plus 4y equals 76. That is actually another strategy. But this time, let's just have the guessing strategy. Let's start with step number 1. What is the problem? We want to identify how many chickens and how many cows are there in the farm of Mr. Jones. So in step 2, we'll just do the guessing. That will be our plan. We do the guessing, then we make a table and we check the pattern and see if it's correct. So example, here's a sample. If there are 20 chickens, and 5 cows, so you multiply 2 times 20 because there are 2 feet for each chicken. That's 40. If you add the 2, there are 25 animals, right? If you add the feet, that's times 2, 40. Times 4, 20. So you add 40 plus 20, there are 60 feet. Not so good. So what will you do? You want to increase the number of feet. So you need to increase, if you see, right? If you only have 21 chickens and 4 cows, the feet will decrease. So if you want to increase the number of feet, you need to increase the number of cows. So for example, there are 12 chickens and 13 cows. You add the 2, you have 25 animals. You multiply this by 2, 24. You multiply 13 by 4, that's 52. If you add them, you'll have 76 feet. If you look back, you check, that's step 4. You add 12 chickens plus 13 cows, that's 25 in all. If you add their feet, that's 76. So that ends our discussion for